Ozone in commercial ornamental tropical marine, fish-only export, and retail systems. Ozone is a potentially harmful allotrope of oxygen and a powerful oxidizing agent with the formula O3. Once reacted, it enriches dissolved oxygen and is created by an electrical spark in air. Overapplication forms hazardous secondary oxidants with the halogen ions chloride and bromide. Highly reactive, oxidized water is crystal clear, bright, and sparkly, yet is toxic and harmful. Total residual oxidant test kits are available but are unlikely to be sufficiently accurate. O3 will also create secondary oxidants within the first 36 to 48 hours following a water change, or when supplementing iodine. Ozone must only be applied within protein skimmers. Ozonisers are simply connected to venturi air intakes whilst pre-drying air using canisters of silica gel. Ozone is useful for oxidizing the phenolic byproducts of microbial nitrification. Phenols are mild reductants that color water yellow and lower oxidation reduction potentials. Some phenols are colourless but deadly. Accumulation inhibits nitrification, clouds water, attacks the central nervous system of fish and increases respiration rates. Phenols can be detected by placing a yellow mark on white paper and holding it at the end of an aquarium. Whilst viewing from the opposing end, yellowing is indicated by a uniform colour. Granular activated carbons do remove phenols, but also remove chemotherapeutics that must be used to control communicable diseases in commercial fish-only systems. Furthermore, dust from activated carbons causes head and lateral line erosion in susceptible fish. The dilemma. If we allow phenols to accumulate, they kill fish and inhibit nitrification, causing nitrite to rise. Water changes are ineffective at removing phenols. If we use granular activated carbon, we cannot control disease. Phenols and activated carbons attack fish central nervous systems, and secondary oxidants are harmful to all life. Hobbyist-grade, oxidation-reduction potential probes and monitors are insufficiently accurate to control potentially lethal substances, but are invaluable barometers of system health. Accurate oxidation-reduction potential apparatus cost over £2,000. So what is the budget solution for commercial aquarists? Seawater with an elevated oxidation-reduction potential is colourless, bright with an unmistakable luster. Due to sterilizing and oxidizing agents called chloramines, Maine's tap water in the UK has an oxidation-reduction potential of around 370 millivolts. It is clear, bright, and slightly sparkling. If we apply ozone to clear, bright water, it creates secondary oxidants, including the water of reef aquaria. Feeding the inhabitants of a commercial fish-only system several times per day sustains nitrifying microorganisms that inhabit the water column. Such plankton populate an ecological niche that may otherwise be inhabited by pathogenic bacteria. Waterborne nitrifying microbes occur rarely in domestic aquaria. After heavy feeds, the oxidation-reduction potential of water diminishes, then steadily rises over a couple of hours to rest just lower than its previous value. Over many weeks, the oxidation-reduction potential falls to a point where water becomes very dull around 240 to 260 millivolts. Once the aquarist observes water becoming suddenly dull, ozone may be safely applied without the risk of generating secondary oxidants. The smallest ozonisers available produce 25 mg per hour. A 500 UK gallon commercial fish system requires only 50 mg for merely an hour every few weeks. After an hour, turn ozone off. Phenols will be mostly oxidized and fish unharmed, leaving oxidation reduction potentials around 320 millivolts.